Hello, everyone. You are lucky to be here with my friend, 𝗬𝗫𝗀. Oh my gosh, everyone know AI engineering? Come on, that book, yes, change your life. Okay, so we're gonna cover practical AI systems and zoom all the way into the 3D world, robotics. And so Chip, first off, can you tell me about the ChatGPT moment you described? When ChatGPT came out, what happened in your mind as a machine learning AI expert?
So hi everyone, my name is Chip. I'm very excited to be here today. So I was just telling John, just like when ChatGPT came out, I had this moment of like, I think I had 2 months of like existential crisis, because suddenly I felt like, what is my purpose? Like if AI can do so many things so well. And I think it's like there are 2 things that I have always like thought of myself as being good at. One is writing, and the other is coding. And both of the tasks are the top tasks that AI could automate. So it took me a while to understand. So I spent a lot of time talking to people, like understanding like how AI is doing, trying to evaluate a lot of tasks, and try to figure out like where AI is headed. And a lot of the learning became the book engineering, and also it helped me understand like what I want to build for the future.
And I thought it's so interesting how like you, an expert, also felt the existential crisis.
I think like there is something about like the more, I think like you would have thought that like, okay, because I work in AI shouldn't catch me off guard, right? But I think that there were some miscalculations, because I had thought that, a lot of people thought that like a small improvement in AI will lead to a small improvement in use cases, right? Which is not true. As a human, we are terrible at evaluating like how useful something is, right? Like if the AI generates something like a little bit like not fluent, we think of AI as being stupid. And then suddenly from not super fluent to like super fluent in like a very short period of time. And we suddenly like before it could do like maybe 10 tasks, and now it can do like 1,000 tasks. So the miscalculation come from like, okay, small improvement accuracy somehow leads to a huge improvement in like usefulness.
Oh my gosh, I felt so much better when Chip said that, by the way. So Chip, physical world.
Yeah.
So you were talking about robots, and robots sitting down, not an easy thing.
So part of my existential crisis after I follow AI more is that I try to decide like what would be the kind of things that AI would not be able to solve in the next like 2 to 3 years, right? I don't want to spend like a lot of energy or like 2 years heads down building something, and then the new version of like Claude or new version of like OpenAI will just like eliminate it, right? So I think I realized something is like the human mind turned out to be a lot easier to model than the human body. So first of all, we can see that AI can answer your legal questions, can help you like write good essays, can write amazing stories, can write amazing programs. But I have never seen a humanoid that can sit down properly. I'm not sure, has anyone ever seen like a humanoid can sit down gracefully? Like there are a lot of funny videos. And you see this like, so actually like a human motion turned out to be extremely difficult to like model. And another thing is that like a lot of time, when for the AI to operate the digital world, we usually have very good documentations, right? Like if we call like, let's say, if we call the GitHub API, we kind of know, okay, these are the functions that we can call. And if we can call with the parameters, here's the expected return code, like what is the form, what are the like types that we can expect. But there's no such thing for physical world, right? There's no such thing as say, okay, for an egg, if we press this much pressure, it's gonna break, right? If we step on the child, it's gonna die. Okay, I'm like, I feel like it's a terrible example. But I'm just saying this like, we only learned about like the environment descriptions and like feedback loop by interacting with it.
Right.
And for AI to operate in the physical world, it has to actually learn all of that. And it's extremely hard to like teach AI all of that information.
There's a really higher accountability in the physical world.
Yeah, like for talking about sitting down, right? Like how do you even describe to a robot, okay, if you want to sit down properly, you have to put the mask here, you have to put the feet here, like you just, because it's very easy to just like flip over when you're trying to sit down.
So when we go from language to the physical world, I mean, you've taught us how to use language. How do we do physical world? What can we take from the semantic world to physical world to say, maybe I can do robots?
Yeah, so actually like the progress in the AI actually makes robotics a lot easier. So anyone here interested in robotics? Anyone here want a humanoid at home to help you do like laundry or like a few? Well, I have bad news for you. It's gonna be a while. So I think like, do you know about Unitary, the company, the Chinese company? That's a very cool robot. So they're fighting for IPO. So Unitary is one of the very, very rare robotic companies that are actually profitable. And they're fighting for IPO. And the CEO has a really good talk. When he talks about robotic intelligence as two things. So one thing is reasoning, right? Reasoning is about, okay, like we ask a robot to like go and fetch me water. Then we need to think, okay, the water is over there. I need to go and pick up the cup, turn on the tap, get water, and bring it to the human. So that's like reasoning and planning. And the other one is motions. So the motion means is that like maybe the robot knows what you do, but if you stand up and then it flip over, we don't think that the robots are dumb, right? So for the reasoning part, I think that it's actually very similar to the reasonings for the agentic AI nowadays. Because like AI is very good at like take a task and reason step by step on how to accomplish the task. So reasoning is something that we can actually like do quite well with AI nowadays. The hard part for reasoning is like the environment feedback. Like okay, like it has to know that okay, if it press too hard, the egg is gonna break. If I put the weight here, then it's gonna fall. So that kind like feedback that we see a lot of people trying to teach AI, what it called like word modeling, like trying to encode information about the physical world, so that AI learn how to operate in it. So we see a lot of startups raising like billions of dollars, right? Like Faithfully has a word modeling startup, 𝗦𝗲𝗀𝗀𝗀𝗃 has a word modeling startup, and there are a lot of like others, fancy researchers starting like companies doing it. So it's very exciting space. The other part is like motions. So a lot of, have you seen the demo of like robots doing like Kung Fu? Or this is really, really cool. So a lot of those movements are actually pre-captured. So like complicated movement, like you program, like, okay, you want to do this punch, then you move this joint like this, right? A challenge or like a holy grail, like to get the robot to generate movement on demand. So maybe it thinks like, okay, if I want to do this, then here's how I should move the joints. So that is still like work in progress. And I think it's a bit challenging for robot to do, but I think that we are getting there. Because if you look at the progress in the last few years, it's actually very promising.
When you think about robotics, there's always the vision part and the motion part. Are they connected somehow?
I think that people thinks that it could be related, but I think there's, so there are like two approaches to it. One is an approach of what people call like the VLA approach, like the vision language actions model, which a robot take in like visual and then language commands and then generate actions to do, right? But then people realize it's like, okay, it's really hard to collect robotic data with actions, right? Because the actions are very much dependent on the body of the robot. So like if you want a robot to walk, then you need to collect actions from robots that have legs. But you cannot collect data from the robots that have wheels, right? If you want to do like 5-finger manipulations, you need a body with like 5 fingers. So people found out that it's extremely expensive and slow to collect action data directly. And then people started to decouple it. Like, what if I just like have a separate word model just to encode information about the world, and then the robot can use that information, visual understanding, to generate actions separately. So yes, so they are like, depending on how you structure it. I think there's their own different bets. Like if you talk to like researchers, they have into very heated argument. So I talked to a company who do like VLA approach, and they said I own the word modeling company as stupid. And then if you talk to word modeling companies, say okay, own these actions companies are like stupid. So we don't know yet. We don't know it works until it works.
I just figured out embeddings and pre-trained foundation models with language, and now more to learn. Oh my goodness. So what should developers pay attention to as all these new primitives come online?
Ooh, so you're asking what should a person...
Developers, what should they pay attention to right now, knowing it's going to start to roll out?
So one thing that like I find very challenging personally is to stay up to date with all the news. It's just like impossible. Like there's so much going on. So actually try to like think about like the kind of problems I want to solve, and I kind of filter out like, okay, does this new thing help solve my problem or not, right? Because otherwise it will say, okay, this company raised a lot of money, this company going IPO, this person doing this cool stuff. I keep getting like pulled in different directions. So try just keep my, like the horses in New York, you need to have a blinder to keep it like very focused. So sometimes I have to like force myself not to like get jerked into different directions just because the new things come out, but like focus on like, one, like, is that problems something I'm interested in? Second, is that like worth solving? Like, is that something that can be solved like by AI in the next 2 years? Then maybe I should probably focus on something else. So yeah, just choose a lane and like, choose the problems that you care about. And maybe my approach is wrong. I don't know. I have friends who like follow a lot of news and they become very popular online and they make a lot of money. And I think that could be great. I'm just not very good at that.
So Chip says to focus everyone, do this, okay? So I'm now sitting with you remembering how it's the Boston Dynamics Spot, the first that robot, whatever.
So cute, yeah.
And I remember that someone told me, never stand near Spot, because when Spot falls, when Spot gets up, it moves not like a dog would move.
So actually like the dogs are actually like a lot safer than say humanoid. So one challenge with humanoids, with robot is like the safety, right? And it's very easy to fall over. Like let's say a humanoid like a G1 is like 80 pounds, right? Let's imagine a chunk of metal, 80 pounds of metal just fall on you. You're in trouble. So there are a lot of things that actually I'm working on, just like for like safety features. So I think one of these companies have a very interesting feature like the 1X. They design the robot so that the robot actually very weak. Like in theory, it could get the robot to be very strong, but on purpose, it makes the robot very, very weak grip power. Like it can't even crack a walnut, a nut, right? So that it makes it safer, so the robot don't accidentally like hurt people by bringing too much force. I also like follows this like they also like design of rules. For example, like never walk too close to humans. Like if some human come close to it, then you step back, right? So like maybe 5 feet of like distance or something like that. So that's something you can do. Another thing is very challenging is like battery. So let's say this like if the robot is walking and it suddenly battery dies, right? Then it's like mid motions and the battery dies. It's gonna flip over. So you need to design the system to detect like, okay, maybe the battery is like this much, then maybe I shouldn't move around. Maybe I should like just pause. Or like, I think a lot of people are developing what is called self-charging, so that when the robot knows that is running out of battery, it should move there. So yeah, so there are a lot of like safety features we need to think about when we bring robots into the real world, working with like real humans.
Okay, if you're tired of LLMs, new frontier, robotics. If you're gonna go into this, you better focus because there's so much noise. Don't forget dog robots, kind of good, sort of safer, okay? Not bad. Watch out for the battery problem. Last word to the audience on what's next.
What is next?
What's next?
Are you asking me what's next?
AI in the physical world, what's next? In a few words.
So I think it's gonna be here. I think robotics, there are two schools of company. One is the companies who believe that robotics can be general purpose, the same ways like ChatGPT and Claude, right? That it can solve multiple tasks at the same time. So there are about like 20 of those companies. So they're very data heavy. So they need a lot of money to like raise a lot of money. The other school of like robotics company is they focus on more specialized robots. For example, here's a robot to fold the laundry. Here's a robot to like cook the food, like packaging. Here's a robot to like just move things around, like delivery. So I think the general purpose company is very hard to predict when it's gonna be here.
You heard it from Chip, general purpose company. A little bit hard to predict, but let's make it happen, everyone. Thank you. Thank you, Chip. Woo-hoo!
Thank you, everyone.
Chip.